Hello, my name is John Peach and I'm a data scientist on the Oracle Cloud Infrastructure Data Science Service. In this module, you will learn about the different ways to manage your encryption with Oracle and customer managed keys, how to use the OCI SDK to store and retrieve secrets from the vault. You will learn about some specialized classes in the ADS SDK that are designed to integrate with the vault. They are designed for the data scientist and the data scientist workflows. They make it really simple to access secured resources that data scientists use all the time. OCI uses encryption in many places in the service. When working with the service, you will be asked if you want to use Oracle Managed Keys or Customer Managed Keys. So, before we discuss integrating the Vault service with your data science workflow, let's review how OCI manages data encryption. By default, OCI will handle data encryption and decryption by using Oracle Managed Master Encryption Keys. Assuming that you have selected this option, when you are provisioning a resource such as a block volume or an object storage bucket or an OKE cluster, Oracle will use one of its master keys to create the data encryption key needed to encrypt the data. So then, Oracle Managed Keys means that the OCI uses the master encryption key from the internal OCI Managed Vault, which will generate the data encryption key to encrypt the data itself. For customer managed keys, the key must be in the customer's vault, and that will be used to create the data encryption keys. Therefore, even if you are not leveraging the vault service, data stored in those OCI services, often referred to data at rest, is always encrypted. You cannot turn it off, which is an important point to remember. When working with many resources inside and outside of the data science service, you will need to choose who will manage the encryption keys. That is, will Oracle manage the key in its internal high security module, or will you manage the key in your vault? What are some of the commonly used data resources that will require such a decision? These would be things such as a block, a boot volume, file systems, object storage, the container engine for Kubernetes secrets, autonomous container databases, OCI streaming pools, and much more. An Oracle Managed Vault has a master encryption key which provides a data encryption key to the respective service to encrypt the data. Thus, any data in the service is encrypted by default. However, when you decide not to use the Oracle Managed Keys, this is where you're choosing to leverage OCI's Vault service by selecting a master encryption key in your own vault. There are various security reasons why you might choose to do this. However, the most common use case is when you are provisioning resources in a designated security zone compartment. In that case, for example, buckets are not allowed to use an encryption key managed by Oracle. You must use a master encryption key that you own in your vault. Keep in mind, the customer managed key selection we see here is not the same as bring your own key option I discussed in the introductory section. Customer managed key simply means that the key is maintained within your vault. Therefore, it could be a key that you previously imported into your vault, or it could be a key that was generated by the Vault service when you created it. Either way, that key belongs to you. You manage rotation of the keys and you are responsible for the life cycle of the key. To set up a customer managed key, you choose that option, as you see here, and then locate your vault. Then you choose the key you wish to use. So the master key is in your own vault. The master key is used to create data encryption keys, which is used to actually encrypt the data. There are two possible approaches to working with secrets using Python. The OCI SDK is a general purpose tool for working with secrets, and it has a lot of power, but its trade-offs are complexity. It is a general purpose API for all things related to the vault. The API is not designed specifically to consider the needs and use cases of the data scientist. Other options are the ADS SDK. It has classes that are customized for data science workflows. We'll talk more about them later in the module. Let us start by creating a set of credentials. Far too often these credentials are stored in the code or configuration file. This is easy to lose track of them, and if you are using them in multiple notebooks or jobs, you have to store them in multiple locations. This is a big security no-no. As a motivating example, let us start by creating some credentials to connect the autonomous database, or really almost any database. We will create a dictionary that has keys for the name of the database, username, and password. The dictionary will be stored in a variable called credentials. Remember that name, as we will see it in a number of code locations throughout this module. We'll assume the vault and key are already created, and we'll now store a secret. You cannot store a binary object used as a Python dictionary in the vault. We're going to have to base64 encode it. To do this, we will need to use the base64 secret content details object. Let us see how to do this. So in this code example, we'll look at the first chunk of code, and we have a helper function that is going to take a dictionary, convert it to JSON, and then base64 encode it. In the next chunk of code, we see that we're creating a base64 secret contents details object. The last line of that chunk of code, it says contents equals and dictionary to secret credentials. This is where we would pass in the credentials dictionary that we saw on the previous slide and convert it to a base64 object. We take that secret content details object and we create a secret details object. Here we're going to pass in a bunch of metadata such as the compartment, the vault ID, the key ID, and information such as a description and a name of the secret. And then the key part of them is the secret contents, which has the encoded base64 secrets in it. Now that we have the secrets, it's time to store it in the vault. The vault clients class takes a configuration object and establishes a connection to the vault service. Let's take a look at the sample code. In the first line, we're reaching out to the OCI configuration file, and we're loading that in and creating a config variable. Remember this config variable, we'll see it in a number of locations. In the next line, the first thing we're doing is creating a vaults client and passing in the configuration information. This information is then passed to the vaults client composite operations object. We get an object of that type, and we call the create secret and wait for state. Here we're going to pass in the secret details that we created in the previous slide, and we're going to tell it to wait until the state is active, meaning that the secrets have been stored in the vault. To retrieve the secrets from the vault, we need to use the sequence clients class and the configuration object. The configuration object is the object that we used before that is called the variable config. Then we use a get secret bundle method that takes the secrets OCID and returns a response object. The response object has a data attribute that returns a secret bundle. This attribute has another method called secret bundle content that has the object in base64 bundle contents details, and a method called content, which has the actual secret in base64 encoding. Let's take a look at how this code would look like. So the first chunk of code is just a helper method that's going to take the base64 object, decode it into a JSON object, and then decode that into a dictionary. The second line of code, the one that starts with secret bundle equals, creates a secrets client and takes that configuration file that we used before and calls get secret bundle, and we're going to pass in the OCID for the secret. That returns back to us a secret bundle, and then as I described above, it takes the secret bundle, calls data, calls secret bundle contents, and passes that information into the secrets to dictionary. And this is going to return back to us a dictionary of all their secrets. Let's take a look at using the ADS SDK to perform some tasks using the OCI Vault. ADS provides a set of classes that make it easier to store and retrieve secrets in OCI Vaults when using the Oracle Autonomous Database, the Big Data Service, OCI MySQL database, or authentication tokens. The ADB Secret Keeper stores and retrieves credentials from the Autonomous Database. It optionally has the ability to store the wallet file. If you're not familiar with this, in order to connect to an Autonomous Database, you need two things. You need your login credentials, such as your username and password, but you also need a wallet file. That wallet file is provided by the database administrator. The ADB Secret Keeper makes this really simple by having methods that will load that and store it in the secret for you and then you'll be able to retrieve that and not have to copy around the wallet file all over the place. The BDS Secret Keeper stores and retrieves credentials for the OCI Big Data Service. The OCI Big Data Service is a Hadoop-based service that's on OCI that also has an HDFS file system. The HDFS file system is a common place to store data that data scientists need to access. The MySQL DB Secret Keeper stores and retrieves credentials for the Oracle MySQL database. There is also an Authentication Tokens Secret Keeper that stores and retrieves authentication tokens or access tokens. This can be used to access such things as streaming and GitHub and so on. In the next slide, I'm going to go over an example of how to use these. I'm going to focus on the MySQL DB Secret Keeper, but all the other objects are basically the same. The MySQL Database Secret Keeper. It understands what is needed to connect to a MySQL database. So this would be things as the database name, the port, the host, the username, the password, that type of thing. Whereas the DB Secret Keeper would store information such as the principal, the Kerberos 5 configuration file, the HDFS host and port, the Hive host and port. The MySQL DB Secret Keeper stores and retrieves secrets for MySQL specifically. It works with the ADS database connection tool as well. So let's take a look at the code. The first thing that we would need to do is import the MySQL DB Secret Keeper. And then we're going to create an object of that class. We're going to give it the Vault ID and the Key ID. So those are the OCIDs for the Vault and the secret key. We're also going to pass in the credentials dictionary. So this isn't encoded. This is the Python dictionary that we talked about in one of the first slides. In order to save it to the Vault, we're going to call the save method, and we're going to pass in some optional information about the secret itself. So we can pass in the name of the secret and the description. All the other information has already been passed to the MySecret Keeper. That was simple to save the data. How easy is it to retrieve it? Well, in best practices, what we would want to do is we would want to retrieve it, but not store it in a variable that's going to hang around. So I'm going to show you an example where we're going to use the with statement, basically create a context. And we're going to load that secret in by calling the MySQL DB Secret Keeper, and we're going to use the load secret. And all we're going to do is pass in the secret OCID. That's going to return back to us an object, and that object is going to be a dictionary, and we can access all the secrets. So it's very simple to use. It's one line of code to retrieve it and 2 lines of code to save it. Let's sum up with what we've covered in this module. You learned that services that can use encryption have their master key managed by Oracle or can be managed by the customer in their vault. You saw how to set credentials can be converted to a Python dictionary, to a JSON, to base64 encoded, and then stored in the base64 secret content details object. That object is stored in the create secret details object along with the metadata of the secret. We then created a Vaults client object using the information in the OCI configuration file. That was then used to create a Vaults client composition operations object, and the create secret and wait for state method was called to store the secret in the vault. Once the secret was in the vault, we could use the OCI config file contents to create a secret client object and call the getSecretBundle method with the secret OCID and get back the secret bundle. The secret bundle has the property of data.secretBundleContent.content that has the base64 encoded secret. That was then decoded to JSON, and the JSON was converted back into a Python dictionary. Wow, that's a lot of work. So you also have the choice to use the ADS SDK to make things a lot easier for data scientists. We saw how to use the MySQL DB Secret Keeper object. All we did was pass in the Vault OCID, the key OCID, and the Python dictionary, then call the save method to store it in the vault. To retrieve the secret, you call the MySQL Secret Keeper load secret method with the secret OCID. That gives you a dictionary of secrets. You have learned that this approach can be used for the Autonomous Database, Big Data Service, auth tokens, and we're developing many more. Thank you very much.